The other problem I'm going to look at is number 4 from section 7.2. It's a car trade-in problem. They tell you that the car depreciates with a rate of change directly proportional to the value of the original car. And it's going to ask me to write a differential equation saying this. On the following page, it's then going to tell me that I have a car with a trade-in value that's currently $4,200. 3 months ago it was $4,700. I want that particular equation. For problem number 4, I'm going to start out with this equation, dv dt equals kv. So the rate of change of the value is directly proportional to the original value. And same kind of thing as usual. I'm going to separate variables. That's going to be 1 over v dv equals k dt. I can integrate both sides. That's going to be a natural log of the absolute value of v equals kt. Remember, you've got to have a constant there as well. I'm going to convert to exponential form. That's a log base e. This is your exponent. I can get rid of the absolute value. I can make that a plus or minus over on the left-hand side. And that'll allow me to get rid of my absolute values. I'm going to let c naught equal plus or minus e to the c power. And so my final function is going to end up being v equals c naught times e to the kt power. All right? Now, if you take a look at the original problem says that the car was worth $4,200 at some point in time. 3 months earlier it was $47,000. Now you can handle this 2 different ways. You can handle now as being t equals 0, and you can view the 3 months ago as being -3. Personally, I would rather view the 3 months ago as t equals 0, just so you're not dealing with negative months. And the value 3 months ago was $4,700. Okay, so we can substitute all of that into the equation. 4,700 is going to be equal to c naught times e to the k times 0 power. Remember, anything taken to the 0 power is going to end up equaling 1. Okay, so that whole thing there is really just 1. It tells us that c naught is equal to 4,700, and as a result, I can take that out of my equation. We've got a 4,700 there at the start. And now I can substitute in the second set of data. After 3 months, this car was equal to $4,200. And so I can substitute that in to solve for my other variable here. In this case, the k variable. I'm going to divide both sides by 4,700. I'm going to divide both parts by 100. I'm going to get 42/47 is equal to e to the kt. At this point, I can convert this into log form. I want log base e, that's a natural log, of 42/47 is equal to k times the t value of 3. Okay, so that's going to equal 3k in this case. And if you go through that process, what you're going to end up with here is a natural log that's approximately -0.112477 equaling 3k. K is going to be approximately -0.03749. So about -0.0375. And so I'm going to put that in. And that's my exponent there. Now, there's a later part of the problem, for example, that asks what happens to the value of the car after 1 year. Well, after 1 year, the way I set it up, I had the 4,700 being the original value. So 1 year would be 12 months after that. And you can substitute that in. You get approximately $2,997.12. So different things, once you get that actual equation set up, you can start to substitute other values and get other solutions.